Hello. You going back down there again?
Yeah, no problem.
Okay. I'm getting ready to teach class, so be careful, don't hurt yourself. Hi, James. Hi, Caleb. Hi, Ben. Hi, Kellen.
Hello.
Well, how's this work? Okay, I was gonna mess around with the portion of the screen this time. Can you only see the first slide of the PowerPoint, not my entire screen?
I only see the first slide.
Cool. I thought it might make it, does it fill up your whole screen?
I would say that's a yes.
Okay, cool. Because I know before it was like showing my whole screen. I was like, I just want them to see the PowerPoint part, that part. So, all right, let's try this and see if this works any better. It looked kind of small when I was watching. I watched one of my videos just to see what it looked like, how it was recording, and see if this works. All right, well, it's 4:01, so I'm gonna go ahead and start. We're covering section 5.1, and I crossed out 2 of the objectives because we aren't covering those. So we're going to identify polynomial functions and their degrees. We're going to graph them using transformations, which we've done that before, as I recall. And we're going to identify real zeros and their multiplicity. So objective 1. All right, a polynomial, basically, if you have x's with exponents, it's a polynomial. As a polynomial function in one variable is a function of the form, and then they write this obnoxious explanation with a's and x's and n's, but the a's are the coefficients in front of the variable x. So those will be numbers. It says where a sub n minus 1, ... are constants called the coefficients. And then n has to be greater than or equal to 0, is an integer. So it can't be a fraction or a decimal. It has to be an integer. And it has to be positive. So greater than or equal to 0 means it's positive. X is the variable. And then they're saying that a sub n cannot be 0 because then you wouldn't have a variable at all, because 0 times x would be 0. So whatever the very first, let's see, whatever the very first coefficient is, that's what they call the leading coefficient. And then the n right here, the n is what they call the degree. And this thing has to be in what they call descending order. So the first exponent is n. Then they've got the next exponent here is n minus 1, and then it would be n minus 2, and then n minus 3, all the way down to x to the first. And then technically right here, it's like having an x to the 0, but anything to the 0 is really just a 1. So they never write x to the 0. It's not there. So if I were to give you an example of f of x is equal to, let's say, 3x squared plus 7x minus 5. And they asked me what the leading coefficient is. This is in descending order. Okay, it is in descending order. It goes 2, this is a 1, and then technically this is x to the 0. So my leading coefficient would be the very first coefficient on the largest exponent, and that would be my degree. So the leading coefficient is 3, and this is a second degree polynomial. But all of your exponents have to be positive whole numbers. When they say, use a different color here. When they say the coefficients of the polynomial have to be some number n that's greater than or equal to 0, has to be an integer. They're saying positive whole number. So the exponents are all positive whole numbers. And that makes it a polynomial function. So if you see an x to a negative exponent or an x to a fraction, that's not polynomial. It's a totally different type of function. The one thing polynomial functions have is their graphs are nice and smooth and curvy and continuous. Now, my example is just of a parabola that looks like this. It has one curve in it. If you have an x cubed, it kind of looks like an S. An x to the fourth looks like that. They're all curvy and smooth and continuous. They're smooth and continuous, basically. All right, so examples here. Identify polynomial functions. Determine whether each of the following are polynomial functions. For those that are, state the degree. For those that are not, tell why not. And then write each polynomial in standard form. And then identify the leading term and constant term. So I tried to color code this. I added the color in there and I drew some lines. But on this slide, I got A, B, C, D, E, and F. And then here's their explanation all written out in detail, but I'm gonna go through it with you in April speak, as I like to call it. So for part A, when I look at this, is it a polynomial? Yes, it is, because all of my exponents are positive whole numbers. So the answer to the first question, is it a polynomial? Yes. And then it says, for those that are, state the degree. The degree would be 3. 3 is the highest exponent. It's this one right there. And then it says, write each polynomial in standard form. This one's already in standard form because it's in descending order. So we're good to go there. And then identify the leading term. The leading term, I'll just call that the LT. The leading term would be the 5x to the third. And the constant term, I'll just use C for constant. The constant would be the -9. The constant would be the number that does not have a variable with it. And so they don't call him a coefficient. He's not a coefficient. My coefficients are the 5 and the -1/4. Those are the numbers that are in front of the letters x cubed and x squared. But since -9 does not have a letter, he's always -9. He constantly remains a -9 until you combine him with something. All right, so then we go to part B. X plus 2 minus 3x to the fourth. Yep, this x is to the first power, and this is to the fourth. All of my exponents are positive whole numbers, so yes, it is. Determine if it is a polynomial. Determine whether it's a polynomial function. That's a big yes. For those that are, state the degree. Now, the degree would be the highest exponent, and that would be the 4. Now, part B is not in standard form. We're going to write the polynomial in standard form. Okay, this one was in standard form. I'm good to go. This one's not. I'm going to have to put it in standard form, and in standard form it would be the 3x to the fourth goes first, the plus x goes second, and the plus 2 would go last. And now I can see that the leading term is the 3x to the 4th, and the constant would be the 2. The leading term will be at the far left, and the constant term will be at the far right. And if you don't see a constant term, then you'd say, I guess 0. You'd have to say 0. All right, now C. Well, when I look at the x, I'm like, hey, that's to the first power. It must be a polynomial function. No, because if you remember, the square root of x is the same thing as x raised to the 1/2 power. So this is not a polynomial function. So when I answer the question on this one, I would say no. And they said, for those that are not, tell why. Because it has a fractional exponent. And that's all I can do there because it's not a polynomial. So, and then H, I did in a lovely yellowy color. That also is not a polynomial because you've got an x in a denominator. I know the x, the x's both have positive exponents on it, but technically this down here is to the first power. If I brought it up, it would then be x cubed minus 1 to the negative first power. And then I've got a power to a power. I end up with a negative exponent on that. You can't have x's in denominators. So on this one, and I don't think the yellow is going to show up very well. It's all right. This one's a no because there's an x in the denominator, which would cause a negative exponent. I'm curious, what did they say? I'm going to look for yellow. Yellow, h is not a polynomial function. It is the ratio of two distinct polynomials, and the polynomial in the denominator is of a positive degree, which means if you bring it up to the numerator, it would be a negative degree. So, makes it easier. I got an x in the denominator. That can't happen. Next, g of x is equal to 8. No, this is not a polynomial function. This is a constant function. All you have is the number 8. This is no, and that's because this is a constant function. If you were to graph that, it's a horizontal line. Oh, okay. I stand corrected. Oh, it's a non-zero constant poly. Oh, that's right. It is degree 0. Okay, my bad. I always forget that. Technically, 8 would be, this is the same thing as 8x to the 0 power. It is a constant function, but I guess they're also saying that it's a polynomial function. Okay. Degree would be 0. Degree is 0. The leading term would be 8, and so would the constant. Is that the same thing they said? Yep, the leading term and constant term are both 8, and it's already in standard form, so I wouldn't have to rewrite this one at all. I'll just highlight that in blue. It's already in standard form. And part F. All right. This one's in disguise. It's in factored form. However, if you were to take this x minus 1 and square it out, you'd get x squared minus 2x plus 1. I foiled that out in my head. And then if I distribute this, I'd have negative 2x to the 5th plus 4x to the 4th minus 2x cubed. That is a polynomial function, and when I distributed it, that put it into standard form. It's in descending order. So the answer to, is this a polynomial function, is yes. It has a degree of 5, and it has a leading term of negative 2x to the 1st, and then the constant term would be 0. Double check and make sure they agree with that. The constant term is 0. Yep. There you go. Now, they do ask a question right here. It says, do you see a way to find the degree of h without multiplying it out? Because I multiplied it out. I foiled this and then distributed it, but let me go to the next slide and show you that. If you were to take this x right here and square it, that'd be x squared, and then take x squared times the x cubed, that would be x to the 5th. So I kind of did it without doing all the work, because I know if I take x minus 1 times x minus 1, first times first, that's x squared. That would be my leading, that'd be my highest exponent in that polynomial. And then I'd have to distribute the x cubed, so I'd get an x to the 5th without actually having to do all of this and then all of that. So sometimes you can just kind of look at it and think about what would happen. And there you go. Okay, now this picture here just talks about what I said earlier about how polynomial functions are smooth and continuous. That's what they said here. It is smooth and continuous. You might want to make a note of this slide because there's a question in my math lab in your homework that asks you about graphs of polynomial functions, and they're smooth and continuous. The next picture is not smooth and continuous because you have a gap right here. There's a gap. And you also have a sharp corner here. They call it a cusp, and a sharp corner there. I guess a cusp looks like this. Anyway, it's not smooth. Smooth and nice and curvy. If there's any pointy parts like this, it's not a polynomial. If it has any holes in it, that's not a polynomial. Smooth and continuous. If you can draw, if you can start at one end of this and trace it the whole way, nice and smooth, without ever having to pick up your pencil and move it, that's where a gap would happen or a hole would happen, or there's no sharp corners or points, you've got a polynomial function. That's one, it's one thing they all have in common when you graph them. They look nice and smooth and pretty. Okay, a power function of degree n is simply f of x equals some number a times x to the nth degree. So if it's an x squared, that's a quadratic. If it's an x cubed, that is a cubic. If it's an x to the 4th, those are called quartics, I think. This little table they've got down here, if it doesn't have a degree, that's called a zero function because that's simply the x-axis. If it has a degree of 0, that is a constant function, which is a horizontal line, much like that y is equal to 8 problem. If you have a degree of 1, That is a linear function. It's going to cross the x-axis one time. It is non-vertical, non-horizontal. It's actually called oblique. A slanted line is oblique. Then we get up to a degree of 2, and you can see the degree of 2 is right there. That's a quadratic equation. It's a parabola. They just kind of go over the first 4 basic ones. Now, the properties of these things. All right, there's 2 types. One is a power function that has a positive even integer. So that would be x squareds, x to the 4ths, x to the 6ths, x to the 12ths, x to the 38ths, okay? Positive even integers. You're not going to be given anything higher probably than an x to the 4th, but anyway. If you have a power function, the function is an even function, which means its graph is symmetric with respect to the y-axis. That's when you fold it in half. If you fold it along the y-axis, the right side matches up with the left side perfectly. The domain, this thing will spread across the entire x-axis. So it'd be all real numbers. The range, however, is the set of non-negative real numbers. This thing should be up in quadrants 1 and 2 only. The graph will always contain the points -1, 1, 0, 0, and 1, 1. It'll always contain these points. -1, 1, 0, 0, and 1, 1. If it's a parabola, it'll look something like that. If it is a x to the 4th, it's gonna look something like, it's gonna, well, I'll leave that for later. As the exponent n increases in magnitude, the graph is steeper when x is less than -1 or x is greater than 1. But for x is near the origin, the graph tends to flatten out and lie closer to the x-axis. The next 2 slides are just pictures of this, of what they're saying. So I kind of added this little at the bottom. You can see on the first graph here, they've got the x to the 2nd power. Okay, so the y is equal to x squared is the black graph. That's your basic parabola. And what they were saying is as x gets larger, the parabolic shape flattens out at the bottom and the sides get more vertical and closer to the y-axis. So you can see it's the blue graph, which I'm highlighting in pink, is flattening out and the sides are becoming more and more vertical. They're not quite as, spread out. And so as they get more vertical, they're becoming more parallel and closer to the y-axis. And then this one over here, here is, let's see, here is y is equal to x to the 4th, which is kind of that's what I thought they had over here. This one here I thought was x to the 4th, but it kind of looks like it over here. And then they went even bigger, or a larger exponent. They went y is equal to x to the 8th, and you can see it's getting even more bottomed out at the bottom, and the sides are getting closer and closer. So they kind of look like parabolas, but they're more bottomed out. The larger the exponent gets, it just kind of flattens out at the bottom and becomes much more vertical. And then this is a picture somebody took on graphing calculators to also show you that if the base, which is x, if x is greater than 1, all right, if x is greater than 1 whole, x is your base, x squared, x to the 4th, okay? So if the base x is greater than 1, like 2 or 5 or 6 or whatever, as the exponent gets larger, it gets more flattened out. You can see the blue graph is x to the 4th. But when you go to x to the 8th, the red graph, it bottoms out and it gets closer to being more vertical. And then the black one is x to the 12th. But when you come over to this one, this is now giving you an example where x is less than 1. So if your base is a fraction, like 1/2 to the 4th and 1/2 to the x and 1/2 to the 12th, it actually goes in reverse order. It's flattening out still, because you can see the blue one is still x to the 4th, the red one is still x to the 8th, and the black one is still x to the 12th, but it's flattening out further away from the y-axis. It's like in reverse, if you can see that. That's what a base of a fraction will do to you. Now, those are the even ones. Now we look at the odds. Remember, if it's an even exponent, either both ends will be up or both ends will be down, depending on the leading coefficient. If the leading coefficient is positive, both ends will be up. If it's negative, both ends will be down. Okay, now for odd, if x is a positive odd integer, then the function is an odd function, which means it's symmetric with respect to the origin. That would be a double fold. If you wanted one part to match up to the other, it's like you have to fold it along the x-axis and then fold it again along the y-axis. And then whatever was up in, let's say, quadrant 1 will now match what was in quadrant 3. Or whatever was in quadrant 2, if you fold it down and then fold it over, it'll land in quadrant 4. So that's what they mean by symmetric with respect to the origin. Both the domain and the range, all real numbers, which is the same thing as saying negative infinity to positive infinity, because this thing's going to spread across the x-axis and the y-axis. Now in this one, the graph will always contain the points -1, -1, 0, 0, and 1, 1. It'll be this point here, that point there, and this point here. And if it's like an x cubed, you know, it has this kind of an SE shape, right? It's kind of got that SE shape. All right. As the exponent n increases, so if you go from x cubed to x to the 5th to x to the 7th, the graph is steeper when x is less than -1 or greater than 1, but for x's near the origin, it tends to flatten out. There'll be that flattening again. So look at that. You can see the original graph was x to the 3rd. That's in the black. I guess I should highlight that in yellow instead. Okay. But then the blue graph, here's the, and you can see that their blue graph is flattening out. It's flattening out right here and flattening out there. So, and over here, they're in this graph, they're showing x to the 5th compared to x to the 9th. It's getting closer and closer. It's like this is getting closer and becoming more vertical as you get larger, but then it gets more flat right here. It's flattening out. It's almost like it's going to become a, there's still a curve there, but it's kind of like that. It's becoming more flat. And then here's just another example, same thing. Oh, I forgot to put it on there, sorry. If your base is a positive whole number, then it'll get sucked closer and closer and closer to the y-axis. But if your base is a fraction, it does the reverse as far as how it's flattening out. That's all they're trying to show you there. Okay, so this says graph. Oh, this is the next objective. Oh, I skipped over that, didn't I? Here it is. Graphing polynomial functions using transformations. We've done transformations before, so it's just kind of a review of that. But it says graph f of x equals 1 minus x squared, x to the fifth. So they actually start with the x to the fifth part right here. That's what they're showing in this first graph, okay? Then they move on to the fact that you've got this negative here in front of the x squared. So it says multiplying -1, multiply by -1, what it'll do is it'll reflex it about the y-axis. So the graph is now doing this. When you put a negative in front of the x, remember it flips it around the x-axis. So it's flipped. So whatever was in quadrant 3 is up in quadrant 2, and what was in quadrant 1 is now down in quadrant 4. And then they took the fact that you have this 1 right here, which technically is a +1, and that's what they wrote. We're now looking at negative x to the fifth plus 1, which is the same thing as 1 minus x to the fifth. That +1 is going to shift it up 1 unit. And it did. It went from being at the origin up to here. And now you're like that. I don't know why I circled this over here. I should have just highlighted the graph. Be consistent, April. So over here, we were just, if you add the 1, that shifts it up 1 unit. So they did 1 step at a time. And then here is an actual example. It says graph a polynomial function using transformations. It says 1/2 times x minus 1 raised to the 4th power. All right, so they started with the fact that it is an x to the 4th. So y is equal to x to the 4th, has that basic parabolic look. It goes through -1, 1, 0, 0, and 1, 4. But then you've got the fact that there's a -1 in here. So that is going to, when you bring that into it, it's going to shift it right 1 unit. So this thing goes 1 unit to the right. And then on this one, they've got a 1/2 in front of it. So that means that your y coordinate is going to be half of what it originally was. And you can now see that this graph is now spreading out more. So instead of 0, 1, it's at 0, 1/2. Instead of 2, -1, instead of 2, 1, it's at 2, 1/2. Your y coordinates get cut in half. And that's the final graph. And you can do it based on solely those 3 original points of -1, 1, 0, 0, and 1, 1, because they all have those points in common. And the next objective talks about identify the real zeros and their multiplicity. A real zero is really just your x-intercepts. If f is a function and r is a real number for which f of r is equal to 0, then r is called a real zero. You just take the function, you set it equal to 0, You solve for x. Hopefully it'll be factorable. If not, you got to use a quadratic formula and hope that it doesn't get too nasty. But those answers that you get, they're called the real zeros. So the following statements are all the same. Equivalent means the same. R is a real zero, a polynomial function f. R is an x-intercept of the graph of f. X minus R is a factor of f, and R is a solution to the equation f of x is equal to 0. It's all one and the same. Here's a picture of the zeros. I think I'll use a pen on this one. Orange. All right. So this point right here, and this point right here, and this point right here, those are all zeros. They are also x-intercepts. Now, when I'm looking at the graph, some things to think about here. When you're at this point, if you look to the left of that point, the graph is below the x-axis, but to the right of that point, the graph is above the x-axis. So that at that point, the function crosses the x-axis. Same thing over here. Before the point, you're above the x-axis. After the point, you're below it. So that's crossing. And one more over here, before the x-axis, or before that x-intercept, I'm below the x-axis. And after I pass it, I'm above the x-axis. So you're crossing. But when you look at this point here, before the point, I'm below the x-axis. After the point, I'm also below the x-axis. That means you are touching the x-axis. You actually didn't cross it. It's like here's the x-axis, and your curve goes up, hits it, turns, and comes back down again. That means your top point right here is hitting the x-axis, but your graph never goes above into quadrant 1 or 2. It's still down in quadrant 3 or 4. And they say that touches it. The other two is crossing the axis. And you can look at it. Because to the left of that, to left of those points, you're either below the axis or above the axis, and then vice versa on the other side of the point. But where I highlighted it in blue, both sides of the point, the graph is below the x-axis, or you could have one that's doing this. Whoops. It's doing that, and it's touching right here. I'm not doing a very good job drawing that. That's also another touches the x-axis picture. Okay, and let's see. And then the last concept, I believe, is the multiplicity. That was the last, was it? Another one. I actually drew this and added it in here because I just needed a good example. It says, if x minus r raised to the m power is a factor of a polynomial f, and x minus r raised to the m plus 1 is not a factor of f, then r is called a zero of multiplicity m of f. I know it's confusing because they've got x minus r to the m, and then they got this, and then over here it says x minus r to the m plus 1. They're simply saying that if this was, I don't know, x minus 3 to the 4th, nowhere else would you see another x minus 3 raised to another power, like 5. I mean, they could have even said m plus 2. You won't find another x minus 3. That's what they're saying. You won't find another x minus r raised to another exponent. Because technically that would be x minus 3 to the 9th. So they're simply saying you only find one of them. And in my example, I've got three different ones. I've got an x plus 2, an x minus 3, and an x plus 5. So my x, the zeros would be the -2, the +3, and the -5, right? If you were to put in here, if you were to put -2, -2 plus 2, that gives you 0. Right here, if you were to put a +3, 3 minus 3, that's 0. And right here, if you were to put a -5, -5 plus 5 is 0. Those are your zeros. As far as your multiplicity is concerned, it has to do with the exponents. When they say a multiplicity of 1, that's because right here, there's technically an invisible 1. But on the next one, you've got an exponent of 2, so it's multiplicity of 2. And on the last one, you've got a 3, it's a multiplicity of 3. Here's what they mean by multiplicity. This function, if I were to write it out so that I saw every single factor, I'd have an x plus 2 times, instead of writing x minus 3 squared, it's an x minus 3 times an x minus 3. And then instead of writing x plus 5 to the third, I could write x plus 5 times x plus 5 times x plus 5. But I'd still only have 3 zeros. This 0 here, is still x equals -2. This 0 is still x equals 3, and so is this one. I've got 2 x is equal to 3's. That's why they say it's a multiplicity of 2, because you got 2 of them. Does that make sense? And then over here, this x, this would be -5. But so would this one. And so would this one. So I've got 1, 2, 3 -5's. That's all that means, multiplicity of. I got 3 of them. But the short way to write it is x plus 5 cubed instead of writing it all out. Okay, so here's their example. Consider the polynomial f of x equals blah, 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 blah. A says find the x and y intercepts of the graph. Use the x-intercepts to find the intervals on which the graph of f is above the x-axis and the intervals on which the graph is below, and locate other points on the graph and connect all the points plotted with a curve. I'm just going to show you their example. The y-intercept is when x is 0. So they just stuck 0 in place of all the x's and solved, got -2. The x-intercepts is when y is 0. So they set this thing equal to 0. And then, of course, this x right here, that would be -1. And this x right here, that would be a 2. So your x-intercepts are -1 and 2. And then it says the two intercepts divide the x-axis into 3 intervals. So here's the x-axis. Here's -1, here's 2. And when it says it divides it into 3 intervals, this interval goes from -infinity to -1. This interval is from -1 to 2. And this interval is from 2 to infinity. And then it says, since the graph of the function crosses or touches the x-axis only at x is equal to -1 and x is equal to 2, it follows that the graph of f is either above the x-axis or below the x-axis on each of these 3 intervals. Let's see. When you have a multiplicity of an odd number. So a multiplicity of 1 or 2 or 3, sorry, an odd number, a 1 or 3 or 5. Remember that odds have this kind of a look, so they're always going to cross. But evens have a parabolic look, so they're always gonna touch. And since my x equals -1, which is this point right here, since there's a multiplicity of 2 on this, right? It's a multiplicity of 2. This has to touch it. And since this is an x cubed, it's gonna, that curve on the x cubed is gonna do this. And then it's gonna come down and curve again and then cross at the 2 because the 2 technically is to the first power. Now what they did is they came up with a table here to show you this. What did they obtained 3 additional points. Oh God, I don't teach it that way. If you know what the graph looks like, you don't have to put in all these points. So I'm just gonna go here. Here's a picture of it. I knew that the original function was an x cubed if I were to multiply it all out. Remember that one example where it said, is there another way? Can you figure out a way to figure it out, you know, what the degree is without actually multiplying it all out? And when I look at this, I've got an x that's squared, and then I have an x to the first. That would be an x cubed. And it's a positive x cubed because this is a positive and this is a positive, which makes that a positive. So I know it has this kind of a basic look to it. It's got to have that. So with my 2 intercepts, x-intercepts at -1 and +2, and I know that this one, the -1, 0, has a multiplicity of 2, it's going to have a parabolic look right there. And then over here, it's going to have more of a linear look, so it's going to cross, if that makes any sense. So multiplicities of 2s, 4s, 8s, it's going to touch it. It's going to kind of look like a parabolic right around there. But multiplicities of odds are going to cross it and have more of a linear look. All right, so here you go. This is what I just said. If it's an even multiplicity, it touches. If it is an odd multiplicity, it'll cross. And then if you're talking about turning points, that's how many times you'll go up and down hills, you know? If f is a polynomial function of degree n, then the graph has at most n-1 turning points. So if you look at that x cubed graph real quick, the x cubed graph looks like this, basically. There are only 2 turning points. This is a turning point here. I go up, I go down. And then this one is I go down and go up. You're switching from increasing to decreasing and then decreasing to increasing. That's 2 turning points. And of course, if it's an x cubed n would be 3, and 3 minus 1 is 2. Now it does say at most. At most. It's possible you may only have 1 turning point on some of these. It just depends on the graph. But you wouldn't have any more than 2. So here's some identify the graph of a polynomial function. Which of the graphs could be the graph of a polynomial function? Only the ones that are smooth and continuous. And that would have to be B. B is smooth and continuous, isn't it? And D is smooth and continuous. You love my side effects, sound effects. This one has a gap right here and an open circle. So this is not. And this one has this sharp point right here. So this is not smooth and continuous. And again, I did the color coding thing, so it makes it easier when you're looking for the answers, but so A is cannot be polynomial, B could be the graph of a polynomial, C cannot be, and D could be. So I got that right. And then this is the last thing we talk about. Yes, the end behavior. Okay, when they talk about the end behavior, they're talking about what's happening basically at either end of your graph. It says for large values of x, either positive or negative, the graph of the polynomial function, and they wrote it out like it's all an expanded notation, but it'll only resemble the graph of the original, the very first term right here. So when it's all expanded out, it'll simply look like whatever, it'll have the basic shape of the very first term. So even though I might have a graph, you know, that works out to be like a 2x squared plus 5x minus 6, it will simply have the basic shape of the 2x squared. It'll resemble that graph. That's all they're saying. And then they have pictures here, and I drew some lines in it to help separate them. On part A, this is where n is greater than or equal to 2. It's an even function. It's got that W shape. And you will look at the ends. When I say the ends, I'm always looking at the ends of the graph right here. They are both going upward because it was a positive whatever. This one, they're both going downward because it was a negative whatever. But those are both even exponents. You know, like I always talk about the x squared, it's either smiling at you or it's frowning at you. The same thing works with x to the fourths, x to the sixths, x to the eighths. Doesn't matter how many little curves you have in between them, the ends actually go both up or both down. However, for the odd ones, the odd ones, if you look at their ends, one end will be down and the other end will be up. This is when your A is greater than 0, so it's a positive. If it's a negative, then one end, the left end will be up and the right end will be down. Because if you were to trace, like if you took a pencil from left to right on your graph and traced it, as you're moving from left to right, this part right here keeps going up and up and up. It ends on a positive note. So something like this would have a positive x to the odd power. But on this one, the last one here, when I'm going from left to right, it keeps going down. So it ends on a negative note. So this would be a negative x to an odd power. These two back here, this would be a positive x to an even number. This will be a negative x to an even, sorry. We're looking at the coefficient. If it's a positive x, both ends are up. If it's a negative x, both ends are down when your exponent is even. If your exponent is odd, you're going to have the first end will be pointing down and the second end will be pointing up. But if it's a negative, it'll be the reverse of that. And what's this want to know? Which of the graphs could be the graph of f of x equals x to the fourth, blah, 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 blah. Okay. starting with the fact that it's an x to the fourth, I know that it's a positive. So both ends should be going up. This end goes up, this end goes up, this end goes up and up and up. But D is out because those ends are going down. So it can't be that one. Because it's an x to the fourth, at most, there'll be 3 turning points. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. That one's out. And then the only other thing that I can actually utilize to my advantage would be the fact that the constant term here in the end is a -6. That's your y-intercept. So I've narrowed it down to A and B. And my graph has to have a y-intercept of 0, -6. It should be crossing the y-axis at -6. This one here is in negative land. This one here is up above. That's in positive land. It can't be that one. It's gotta be B. Process of elimination. The next slide just gives their explanation. You can read that later on your own. And then this one says, write a polynomial function whose graph is shown. Okay, well, I know it's got 3 x-intercepts. It's got this one here. So since right here, this is x would equal a -2, that means that it came from an x plus 2 equals 0. X plus 2 is one of my factors. This one has an x coordinate that's equal to 0. So x is another factor. And then this one is x is equal to +2, which means that came from an x minus 2 equals 0. So that's a factor. So what I have is x times an x plus 2 times an x minus 2. That's my polynomial function. And do they, let's see, did they leave it like that or did they simplify it out? Oh, wait. Yeah, I forgot my multiplicities. I have one point that is touching this one right here. Let me use another color. How about purple? This right here is touching. So that means it has a multiplicity of 2. That should be an x plus 2 squared. The red one is crossing, the green one is crossing, so those are to the first powers. So I think they just left it like that, didn't they? Yep. Okay, where are you getting the 2 from? Well, they went a little further. They couldn't decide if x had a coefficient or not, because this x right here in red, I suppose it could have been a 1x or a 2x or a 3x or a -6x, because any of those x equals to 0 would give you x is equal to 0. So they threw in an a right here. And then they were like, okay, that's what this extra point is for. This point right here is an extra point on the graph to figure out what a is, they stuck the -1 here and here and here. So a times -1 is -a. -1 plus 2 is 1 squared. -1 minus 2 is -3. I got 3a. The hell? Oh, sorry. Hello, April. Equals f of x. So equals 6. So this gives me 3a equals 6. So a is equal to 2. And then they stuck that in there. So they've got 2x times x plus 2 squared times x minus 2. And I guess if my math lab wants you to simplify that out, which I hope they don't, you'd have to. And that's the final answer right there. Fun times. All right, I need to get to my math lab. Oh boy. I'm supposed to cover 5.1 and 5.2 today. It's not going to happen. All right. Number 1 says, is this expression a polynomial? And if so, what's its degree? I look at all the exponents. There's a 3 and there's a 2. Don't get confused and think that this guy right here has anything to do with it. Most people are like, oh, there's a square root in there. That means it's a power of 1/2. True, but there's no x on that. There's no x here. You're good. If that had been x, the square root of x, then I would have said, no, it's not a polynomial. It is a polynomial, so it is a polynomial. And then the degree is the highest exponent, and that highest exponent is the 3 right there, because it's in descending order. Square root of 2 is your constant. It's your constant. Okay. Complete the sentence below. When you're in my math lab, these are going to be drop-down boxes, all right? There'll be a drop-down box, 1, 2, and 3. I had printed out the homework and took a screenshot of the printed version. The graphs of power functions of the form f of x equals x to n, where n is an even integer, always contains the points blank, blank, and blank. So on the first blank, here, it'll be this drop-down box. And so one of the points, if it's even, remember if it's even, the first point would be right here. And that is -1, +1. So I would click on this. And then the second point, that's going to be this drop down box. The second point was here, and that was 0, 0. So I'm going to click on that. And then the third box is going to be this one. That would be this point right here, and that is 1, 1. So 1, 1. That's something you're supposed to remember. Number 6, determine whether the following function is a polynomial. If the function is a polynomial, state its degree. If it's not, tell why not. Then write it in standard form and identify the leading term and the constant term. Okay. It's a polynomial function because it's got an x squared and then an x2, an invisible 1 right here. So it's a polynomial. So I'm clicking on that. And then it has a degree of 2. And then the next question pops up. This is the first question. Write the polynomial in standard form. The only thing wrong with it is it's not in descending order. So I would simply write the x squared first and the plus 2x second. And then that means that the leading term is the x squared. And the constant is, I don't see a constant. There's no constant visible, so you'd say it's a 0. And that's all they wanted me to do on that, right? Yep, that's it. Number 8. Okay. This one says determine whether the following function is a polynomial function. And they do want you to write this one out in standard form. So I'm going to go ahead and do the math. I left some space here. I would start with this x minus 1 squared. That's an x minus 1 times an x minus 1. That would be first times first is x squared. Outside is negative 1x. Inside is negative 1x. That's a negative 2x. And last times last is a plus 1. But I have this 2 in front of that. So if I distribute the 2, that's going to be 2x squared. Let me move this up here. 2x squared minus 2x plus 1. But then I also have this x squared plus 5, that's still there. And in order to
Wouldn't it be 4x, 2x squared minus 4x plus 2?
Oh, yes, it would be. I'm sorry, I'm not very good at math. I've made that joke before, haven't I? Minus 4x, yes, thank you. Okay, and then I would have to distribute, and it doesn't matter which way you distribute. I'm going to distribute the x squared from the back to the front. That's going to be 2x to the 4th minus 4x cubed plus 2x squared. And then I would distribute the 5 to these things also. And that's going to be 10x squared minus 20x plus 10. And the only like terms that I have on this sucker are these two. Oops. Are these two? So my final answer would be the 2x to the 4th minus 4x cubed plus 12x squared minus 20x plus 10. Okay, so it is a polynomial, that is for sure. It is a polynomial of degree, the highest degree is the 4. And then this mess of an answer right here, that is what I would type in right here. And then the leading term is the 2x to the 4th. And the constant is at the other end, it's the 10. That was fun. All right, next problem's a lot easier. It's just look at the graph and pick an answer. We like these. Okay, it's a negative 2x to the 5th. Okay, because it's a negative x to an odd power, it's going to have that SE shape, but it's going to start up top, come down and curve and finish going downward in the negative direction. So that automatically eliminates B, because B ends going upward, and C, because that also ends going upward. A ends going downward, and D ends going downward. And then I have to choose between A and D, but if you look at D, D got shifted. Looks like it got shifted from the origin to the right and also up. This basic graph right here is the basic graph of x to the fifth, which should go through the points. What was it? -1, 0, 0, and 1, 1. Of course, they put the negative in front of it, so that flipped it around. And when you put, let's see, when you stick that negative in front of it, this is now going to be, it's gonna go the other way. So it's going to be -1, +1, still 0, 0, and 1, -1 now. So that's got to be A. But because you've got, I need another color here, because you've got this coefficient of -2 multiplied onto that, then that makes it, when x is -1, you'll have, it's going to be 2. This will still be 0, 0. And this will be 1 to the fifth, -2 now. And that's what they're showing here. -1, 2, and 1, -2. The 2 is going to stretch it, you know, it's going to stretch your graph so that it gets closer to the y-axis. So, but based on 0, 0 alone, really, that's all I needed on this, because this one here, that got shifted, that 0, 0 got shifted to the right and up. So it would be more like, you would have an x, well, let's see, it went to the right, which is in my head positive, but that would be -1 to the fifth. And then it also went up 1, so you'd have to, or actually it went up, since that's labeled as a 10, 2, 4, 6, 8, 10. It went up 2. That would actually be the graph of that one. You know, doing all that shifting crap. Like this one. Okay, it is an x to the fourth. It says the basic transformation of x to the fourth. So when I'm looking at, this is a positive x to an even power. So I know both ends have to be going up, and it's to the fourth, so it's more of a flattened out, you know, parabola. Not real flat, but more flattened than a regular one. It's got a coefficient of a 7 on it. Let's see, but they have shifted 1 to the left, right? They moved it 1 to the left. And then this one means it moved up 1. So it went from 0, 0 to 1 to the left and up 1. C. It's got to be C. Because of both ends are going up, that took out A and B because the ends are going down. And then I just used the shifting stuff to see where it shifted. It's supposed to go 1 to the left and up 1, which would put it right here. Okay. Wow. I want to go look at, where is, I thought I was logged into our course. I guess I'm not. Oh yeah, I am right here. Let's go to the syllabus. You can see this. Today is the 28th, and I was supposed to cover 5.1 and 5.2. I obviously didn't finish that. So, it's Wednesday. I'm going to continue on next Monday with where we left off. So I'll have to extend, obviously, the 5.1 and 5.2 homework because I haven't finished it yet. So you guys are in luck. I'll be extending those another week, and we'll just keep working until I get through this. I'll just have to keep, working on stuff until we're done. Sound like a plan?
Thank you. Good plan.
Okay, you get a little reprieve. Bye. You've been a lovely audience. Tip your waitresses.
Bye.
Bye.